All right, we're going to continue with infrastructure security with the VPC DNS settings and private hosted zones. Okay, so this will be a walkthrough of how to configure DNS settings in the console with some examples, right? So this is essential for the security specialty exam because DNS resolution is a core part of securing, isolating, and controlling network access within and across VPCs. So here's some concepts that you could get. DNS settings. All right, let's see if we can find this. Let's go DNS. Nope. And there's a white paper on this. All right. Okay, so here's information about DNS. This will be included in the description. So AWS provides two key attributes for the DNS configuration in a VPC, right? That's enable DNS support, which enables the DNS resolution via the Amazon provided Route 53 resolver, and then enable DNS host names. So this allows instances with public IPs to receive corresponding public DNS names. So these must both be enabled to, one, resolve public domains like google.com, and two, use private hosted zones for custom internal domains. So an Amazon DNS IP. So there's an example of, let me go down here. So what's a static IP? All right, so here's an example of one. Well, that CyberBlock would be kind of an example, but this would be something that you could have static. However, you'd want it to be more specific. So 254, 169, 253, right? So this would be an example. Then there's a VPC +2 format. So there's a base CIDR block and then a secondary CIDR block, right? So you could have it 10.0.0./20, right? And for a secondary CIDR block, you could have 10.100.0.0/24, right? So in that instance, you'd have a separate CIDR attached to the second CIDR. All right, but let's go back to the VPC. So let's go to the console or the VPC dashboard. Let's go to our VPC. We don't have an active one, so let's go to the default one. So let's say you go to actions. Let's go edit VPC, and so enable DNS resolution. So here it is, right? DNS resolution attribute. It determines whether the DNS resolution is through the Amazon DNS server, which is supported for the VPC. Okay, so if you enable this, you click that, it lets the instances resolve names via the Amazon DNS resolver. And then you enable DNS host names, right? Determines whether instances launched within the VPC receive public DNS host names that correspond to their public IP address, right? So this assigns DNS names to instances with public IPs. At this point, you click save. I'm going to click cancel though, right? So then we want to create a private hosted zone. So how do we do that? Route 53. I'm going to let you know, Route 53 is not usually used in the office unless you have a major enterprise setup, just because it has a lot of cost to it, right? So you might want to do a more, not a AWS managed DNS manager, okay? So let's try and find this from, let's see, would it be a migration? No. Networking, there we go, Route 53. All right, so from here, look on the side for hosted zones, create a hosted zone, and then create a hosted zone. All right, so we get the domain name, so say demo.internal. All right, and so this would be, let's say, a private hosted zone with the VPC association. So we are global. Let's go for US East. And then we'll choose our default VPC. And so for this, if you have both of those DNS settings, we need to have those checked earlier, but we just both did the DNS resolution and the DNS host names, right? And at this point, you can add your tags and click create host name or host zone. Okay. So let's go to a custom record name. Okay. So, oh, I already have one. Okay. Let's see. So within this, we could create a record, right? So within this, we can create a record and then add a record name. So here would be, let's say, google.demo.internal, right? How this would be routed for the record type. So CNAME, this routes traffic to another domain name and to some AWS resources. So you can use this for other resources, Google in this case, right? And then the value, google.com, and then you create the record, right? So it's a simple routing, weighted routing, geolocation. This is how AWS would manage this, right? So it's programmed in there. And you click create the record, right? And then you could test the DNS resolution. And this is where you would use dig. So you would dig google.demo.internal, and then you'd have an expected output of a CNAME pointing to google.com, followed by an A record with Google's public IP address. Okay, so remember this. The VPC DNS attribute enables DNS query logging when paired with the resolver query logging. All right, this is revolving around the security specialty. Private hosted zones. This limits external exposure of internal services through the private DNS. DNS resolution across peering. This supports secure, scalable, multi-VPC networking. Custom domain names enables masking of internal resources and secure name-based routing. Resolver usage and logging. This validates control and visibility over which services perform lookups internally. So remember, always enable both the DNS settings for internal private resolution to work. Use private hosted zones to prevent exposure of internal services. Validate the DNS resolution using a bastion host, like we mentioned in a previous lesson, or an EC2 instance. And then integrate this with CloudWatch logs or VPC logs, VPC flow logs to track DNS queries. And then avoid depending on public DNS names when isolating production environments. A couple of additional notes. Route 53 private hosted zone costs about 50 cents per month per zone. VPC DNS resolver is non-configurable for filtering or security groups. And in EC2 instances, receive DNS host names only if the settings are enabled. Okay, and then no DNS resolution across a VPN or direct connect from an on-prem to a private zone unless you're using Route 53 resolver endpoints. So let's go to VPC endpoints. Okay, we'll talk about VPC endpoints, including gateway and interface endpoints in the AWS console. Explain how they relate to security within infrastructure and the exam. Okay, so how do you understand VPC endpoints? There's two basic types: gateway endpoints, which support Amazon S3 and DynamoDB only. And then these are routing based. There's no security group management, and they're used instead of NAT gateways or internet gateways for accessing AWS services privately. Okay, then there's interface endpoints. These support most AWS services via private link. And with these, you create an elastic network interface, an ENI, and a security group is required. But there's also an optional private DNS integration for transparent access. So how do you create a gateway endpoint? So we're in the VPC dashboard, and we are going to go to endpoints, which are, that's mirroring, where is it? Endpoints, okay. Endpoints. Okay, so you click create endpoints, service category. Let's give it a name. AWS, let's say my practice endpoint. Okay, we use the AWS services and the service name. Let's go for oops. Let's try S3. S3 service name, comment, use one, S3. Okay, we have S3. We'll do a gateway. We choose the VPC. Then we could choose the route table. There's only one route table for this, 6 subnets. Okay, select the route tables associated with this, with the private and subnets. Okay, and then we have policy options, right? So you can choose between full access or custom. So you can restrict it to certain actions like list in the bucket, put object in the bucket, etc. Or resources, like a specific bucket ARN, right? That would be the resource name for that specific bucket. And then once you're done, so you create that in this here, right? But we're not going to do that, right? We're actually not going to create this endpoint just because it is very useful to see how it works, but it's basically private communication within your cloud, okay? And then you click create an endpoint. And then you could go to the route tables, verify the route, shows the prefix for S3 VPC. So the prefix would be you'd see this VPC E dash, and then the unique, okay, VPC E, and then the unique identifier would be something like A, B, C, C, D, E, 1, 2, 3, 4, 5, 6, something like that, right? But it'll be about that 10 digits after the VPCE prefix. Okay, so then you have a prefix. You have the interface endpoint. All right, so we can do this again with, would be very similar. Okay, so let's see. So let's look for one for secrets manager. So secrets manager, okay, secrets manager selected here. And then this is the type here, interface. Okay, so you choose the VPC again, right? And then this must be inbound. Okay, so we have the enabled DNS name. Okay, so then we have the IPv4. Then we select one subnet per AZ. So 1, 2, 3, 4, 5, 6. Let's just select all of them. All right. Okay, select these. Okay. And then private DNS is enabled by default. So this ensures that secrets manager dot, whatever region we're in, I think it's US East 1 dot Amazon AWS.com resolves internally, right? And then we have our security groups. We can do the full or custom access, add whatever tags we need, and click create. Okay. And so this should work without the internet if the VPC endpoint is configured correctly. Okay. So let's go back. So here's some key concepts. VPC endpoints control who can access services via the endpoint. They can be attached to both gateway and interface endpoints, and they're evaluated alongside IAM policies and resource policies. So let's see. Oh, let me give you an example of a couple of policies you could look at. S3. Okay. Select. So a custom policy for a gateway would look like this. All right, this is text. All right, so this would allow, this has the effect to allow this ARN for this role, right? And the action would be list bucket and get bucket, right? So you see all the objects, and these would be the specific buckets. So my bucket and anything under my bucket with that indicated by that star. Okay, and then so you could validate and test this by going to the VPC. Let's see, VPC. If you have the enabled DNS support and DNS hostnames like we did earlier, those are set for true. And the security group rules are allowed for TCP for 443 from the calling resource and TCP 443 for an outbound rule to the endpoint IPs. Then you need to ensure the traffic is allowed for the ENI, which we talked about earlier, the Elastic Network Interface IP range. And then you would be able to validate it, make sure everything's on and running. Okay. So let's continue. All right. So the next step we're going to go towards is going to be private link, which we talked about a little bit earlier. All right. So private link allows you to securely expose services in your VPC to other VPCs without using public IPs, internet gateways, NAT devices, or VPC peering. It does this through endpoint services on the provider side, interface endpoints on the consumer side, elastic network interface, ENIs, and network load balancers, NLBs. I believe that's at layer 7, or no, layer 4, excuse me. So here, a specific use case would be you want to expose a private service hosted in your VPC to multiple consumer VPCs in the same or at different AWS accounts securely and at scale. So one thing you want to do is create a private link endpoint service. Okay, is that private link? Private link. So you'd need a VPC with at least 2 subnets in different availability zones, which you technically do. Ooh, you need a network load balancer, which I don't think we have. Mm. Okay, so you need to get that network load balancer configured, right? Create this. We're not going to create this. right? But this can balance the load of how networks move within your internal network, right? So we're going to do internal my practice LB. Oops. All right. IPv4, dual stack, the VPC, that's the VPC. Availability zones, we'd select all these. There's not a, oops. Which one is it? I thought one of these, are these all public? Uh-oh. I swore it's not a private subnet. Okay. Some reason I thought this was, that's okay, but this is how we would set this up and enable the network load balancer once we, okay, I got the security groups on here, listening ports, and any default actions that we want to forward, any tags that were relevant, and then load balancing, and then global accelerator is to balance this and speed up the traffic. But this would be for a for something you need high throughput, low latency across multiple regions. So this, something like CloudFront, they would be very related. But unless you're doing something high impact, like a 4K television stream across Netflix, think Netflix, you really don't need global accelerator or CDN. And then you click create the load balancer. But we're not going to create that, but I'm just walking you a brief walkthrough. Okay. So, but in VPCs, okay, to create the private link, in VPC, go to endpoint services, create this. Okay, my endpoint service practice. And then you choose the load balancer. So we don't have one. You could create one here, right? You can select an existing one, or you can enable and create one, right? And at this one, you check your regions that you want this to balance over. So say we're all to US. Right, let's select all US. Okay. Additional settings, supported IP drive. We do IPv4. You could do IPv6, but not many places are using that. And it's going to cost more right now. Then click create. Okay. And then optionally, you can associate a private DNS name. So in the details, you would be able to choose to associate a private DNS name like api.internal. Whatever your company name is .com, Google, Walmart, whatever, and then validate the domain ownership via a DNS text record in Route 53. So there's a lot of moving pieces here. So once this is done, you can grant access, right? So in the allowed principals, you can add the AWS account ID to use the service, add that principal, and you'd be good to go. Okay. So then you need to add an interface endpoint on the consumer side. So let's go. So you go to VPC console, you go to endpoints, create an endpoint under the service category, select other, private link. No, wait. Why am I not seeing other? Service category. Why am I not seeing this? Huh? EC2 Connect endpoint? No, that's not it. Endpoint services there. I think this might be it. Yeah, this is it. This is it. So this is the other. Okay. So, geez Louise. And so what you created over here will produce the VPC endpoint dash service. And then you put in the service name. So it would be something like com.amazon AWS .vpc endpoint dash service dash, and then whatever the specific ID would be, 1, 2, 3, 4, 5, 6, A, B, C, D, E, F, something along those lines. You'd verify it, enable cross-region endpoint, and then click create. Well, then you select your VPC as well if necessary, but it shouldn't be. And then click create endpoint. Right, so how does this work? The provider network load balancer routes traffic to the backend service. The consumer creates a private connection via the ENI, and the traffic never traverses the public internet. Okay? So you can also do a validation checklist, so we can do a DNS resolution to verify, either using NSLookup or DIG. And you can then also make sure that your security group allows port 443. And then at this point, you can confirm traffic reaches the backend, say in CloudWatch or Apps Logs, and you should be good. I'm going to cancel this and cancel this. Okay, so how's this relevant, right? So for incident response, this would be reducing exposure surface by eliminating public endpoints. For logging and monitoring, you could use that VPC flow logs, the network load balancer logs for monitoring access. For infrastructure, you would avoid VPC peering blast radius, right? So you least privilege per endpoint using the policies. And then for identity and access management, you'd restrict that again with the endpoint policies and allowed principles. For data protection, all traffic will stay within the AWS private backbone. Okay, so to summarize, private link is the gold standard for exposing services across accounts and regional securely. It replaces VPC peering, NAT gateways, and public IP access. And mastery of private link is essential for your working environment and the AWS Security Specialty exam. Next, we'll go to NACLs and security groups. Okay, so we'll go into some core concepts that I hope give you an idea of NACLs. Let's see. So how do NACLs versus security groups? Let me see if I can get a table here. Insert table. Okay. Aspect. So NACLs, network ACLs, and then security groups. Okay. All right. And so let's see if I can copy paste this. Maybe this will work. Nope. That didn't work. Maybe this will work here. Nope. All right. So how do these operate? NACLs operate on the subnet level. Security groups operate on the instance level. What rule types do NACLs have? Allow and deny. Security groups have allow only rules. What is their state? NACLs are stateless. Security groups are stateful, meaning they have a memory, essentially. What's the rule evaluation? NACLs are ordered by rule number, lowest first. For security groups, all rules are evaluated. Traffic flow for NACLs is both inbound and outbound are elevated. And then for security groups, return traffic is automatically allowed. For the scope of NACLs are all instances and associated subnets. In security groups, only instances explicitly assigned. For NACLs, the default behavior is the default NACL allows all traffic. For security groups, the default security group allows all outbound, no inbound. Okay? Let me see if I can give you a workflow. Oops. So, okay, this should make a little more sense. Okay? All right. All right. So you have internet. The stateless goes both ways, right? Internet to the NACL, to the security group, to the instance. And then remember that the NACL is subnet level and stateless. All right. And then the security group instance level is stateful. So return from traffic is autoflow. All right. So how do you access the NACLs? Okay, so let's go into the VPC. And then we'll go to security, network NACLs. Okay. So understanding the default NACL, right? Every VPC has a default NACL. The default NACL allows all traffic inbound and outbound. And this is associated with all subnets by default. So here's something critical: never modify the default NACL in production. Okay, you might be able to tinker with it in dev or development or release control, but you should probably get the good idea to not do that. So here's some default setup for NACL. Okay, so here's how the inbound rules look. All right. So default, the rule 100, all traffic, protocol, port range, all, source, all, and then allow or deny, right? And then the outbound rules, oops. All right. So for this, you have something similar, right? No, it's pretty much, it's exactly the same, right? So the outbound rules are the same, okay? All traffic, ports, protocols, and then allows or denies, right? So how do you create a custom NACL? Let's show you that one. All right. You click create. Let's say custom practice NACL. Select the VPC. Select our default. Then add tags for this. Let's say name, custom. Yeah, that'll be fine. Okay. And then we click create. And then boom. Click on this. Configure inbound rules. And then you could set by, let's say, add the rule. What's the rule number? 100. Add a new rule. What's a new rule? 110. So 100 takes more priority. A new rule, 1000. A new rule, 32,000, something along those lines, right? And then you could do this for, let's say, HTTP. You need to know what protocols and why you need them. But let's go HTTPS. Let's say SSH, and then all traffic. All right, so this would be good. All right, and so for SSH, I probably want to update this to 10.0.0.0/8. And then for all traffic, I'd have this on a deny, right? So that the explicit deny. Okay. And then for outbound rules, right here. All right, so you have to configure this much in a similar way. And so you'd have the allows and then denies. So here's another concept that you need to know: ephemeral ports. So how do you understand this, right? Ephemeral ports are temporary ports assigned by the client for return traffic. So there's port ranges per operating system. Let me get those here. Okay. So Windows has port 49,152 through 65,535. Linux has 32,768 to 60,999. And AWS load balancers has 1,024 to 65,535. Okay, so there's NACL configurations for database access as well. Okay, but you can go into that. But that's basically how do you set this up. There's really NACL access for a lot. You can do it for the web tier, the database tier, and then you can set this inbound, outbound with ports specified by range or by specific port, a specific protocol, TCP, UDP, etc. And then you'd have the destination set for the IP address and an allow policy if you're getting this connect, right? And then how do you associate subnets with this? Okay, so let's cancel subnet associations. So in this, you select this subnet and then save changes. Okay, you got this. You filter this. You could do however you need. Save changes, and then this would be associated, right? So each subnet can only be associated with one NACL at a time. So this one. All right. So we went over security groups a little earlier, but we're going to do this a little bit again. Okay, so security groups. So how do you do this? You create this with the create button. Name is so web SG for security group practice, right? And you'd have web tier SG, and then select your VPC. We only have the default one, and then you'd add your default traffic for inbound, right? So HTTP, HTTPS, gosh, HTTPS. Okay, and then SSH. SSH. Okay, so that's it. Port 80, port 443, port 22. All right, and then set it for inbound. So put this, and then security group. So that the security group for SSH access, and then the outbound rules will allow traffic out. Well, that's fine. Don't touch that unless you're, much more advanced. You can also configure this for something along advanced parameters. So for something like a database or any of these other types here. Okay. So this has a lot of different protocols and purposes. Okay. So there's a lot more you can do here on the application layer, on the database layer, on the web layer, and you can do certain things for compliance. Okay. But remember, some basic compliance rules you should follow for PCI DSS compliance, which is going to be a big factor. That covers credit card payments, right? Have deny all by default, right? NACL rules, remember this. Allow only necessary ports from specific subnets and log all denied traffic via VPC flow logs. And you could do VPC flow logs. So we'll show you here. For this one, and I've shown you this already, but you go here, create the flow log, and this will be good to go. All right. So some security group rules would be, remember the principle of least privilege. Remember not to have wide open rules like the port 00, like the IP 0.0.0/0, and then regularly access review and rotation for your security groups. And for HIPAA compliancy, remember that you can make segments for different subnets. And so you could do this for public health information and then set this up to deny inter-subnet communication by default. And you can allow only audited or encrypted connections between this, right? And then for security group rules, remember to reference the other security groups and not IP ranges, which helps you to lock them down, and then implement defense in depth, right? So that means a lot more of what we've just covered before. So you have to have a mindset of how to create your checklist and cover everything. And then enable your monitoring via the VPC flow logs that you've seen here. Okay, so when do you use security groups? Instance level, they're application specific, there's stateful traffic management, and there's dynamic rule management with some automation. When do you use NACLs? When there's subnet level security, there's defense in depth, there's blocking specific IP addresses, there's regulatory compliance requirements, and stateless traffic inspection. Okay? All right. All right, so next we're going to go to Transit Gateway. Okay, so this is going to be an interesting one, and it will be in this range as well. Let's go to VPC, and then we'll go Transit Gateways. Okay, so from the VPC, configure the Transit Gateway. Gosh, I want to get you some good documentation for this. Let's see. Damn. Nope. I don't. All right. We're gonna create this. We'll name this my TGW practice. All right. And so you can enter a description, an ASN. You can leave it default, which I think is the default is 64512. Oops. Auto accept shared attachments. So this is disabled. So you have DNS support, security group referencing. You could do that. Auto accept. Yeah, I wouldn't do that. Default route table. No, I wouldn't do that. Transit gateway CIDR. You can update this, but I wouldn't add that. And then you have your tags, and you could create that gateway. Okay, and then you could have VPC attachments, right? Which would attach VPCs here. So the transit gateway allows you to have a network that spans multiple regions within your account. So you could have it in the US, in Europe, South America, etc. Be able to have this communication and availability for your resources all over the world, right? Or in a certain region of the world or certain regions of the world. And within this, you'd have VPC attachments for the transit gateways, right? So let's see, transit gateway attachments. And so you create this type. What is this? TGW attachment on a transit gateway that we would have created with the VPC, okay? And then you'd select the subnets in the VPC, boom. And so these would be the subnets. And then from here, you'd add the tags, click create, and you'd be okay. And then, okay. Okay, and then from here, we get the TGW route tables. Okay, create the route table. Let's call it TGW-RT practice. Okay, select the tracer gateway that we created. All right, and then you'd be able to associate that with it. Click create, and this will ensure the traffic from the VPC is routed only to the authorized attachments that we just were looking at. And then you'd repeat this with other route tables if you're segmenting environments. Okay, and then you could go and update the VPC route tables. Okay, so you go to VPC, click on route tables, and select the route table for your private subnet. So that would be down here, but let's just give this an example just to show you here. So you select this, and then you could, oh, there you go, route, edit route, and you'd add a route here, and you'd use the destination IP or destination IP. So, or the CIDR used in the connected VPCs, right? And you target the transit gateway down here, okay? And then you'd repeat this step for other VPCs you connected. If you had one in Tokyo, Europe, South America, etc. Okay? And then, how do you apply security controls with this? Okay? So you pretty much have it all linked in. But that comes into the two things we just discovered or just spoke about. That will be your NACLs, your network ACLs, which would go to the subnet level, right? With those subnets that we see over here. And then you could have security groups, right? And so you connect security groups that would go to the instances for only the ports that you need. So that'd be SSH or HTTPS or HTTP if you need a bastion host, which we spoke about earlier. So you should use security groups to reference the security groups rather than the CIDR block. So it creates more dynamic trust boundaries. Okay. And then make sure that you have all of that. Let's see, transit. Okay. Transit gateway. And then make sure, where is, why do I not see this? Uh, mm, mm, mm. Oops. Uh-oh, what did I just hit? Okay. So here, you can modify it and then create a flow log on the created transit gateway. I'm not going to create one because it takes a long time to get it kicking off. All right, so this would help audit your inter-VPC traffic, and it would be relevant for anything about incident detection or network forensics. Okay, so there's different bandwidth that could be given between different connections, right? So there's VPN to VGW, which you covered in an earlier lesson. That'd be about 1.5 gigabits per second, and it's limited, okay? There's VPN to TGW, which is about 2.5 gigabytes per second. There's multi-VPN to TGW, which is about 2.5 gigabytes per second for the transit gateway, right? And that means it's multiplied by how many transit gateways you have. So it can kind of scale a little bit. And there's direct connect to the transit gateway, which that is the highest throughput, which I believe is around 10 to 100 gigabits. So it's a lot, okay? It's a lot. So we're going to go into, let's do a little bit of something different. Let's close some of this out. All right, so let's go for CloudFront. All right, so CloudFront. CloudFront operates as a global edge service that sits in front of your origin infrastructure, and it provides multiple security layers, right? So there's the internet user to the CloudFront edge locations, and then to the origin infrastructure. At the CloudFront location, there's a lot of security controls applied, right? So geographic restrictions, you don't want anyone from Korea, or if you have something, you have your DVD or your streams from Netflix or Hulu or whatnot, that licensure might not be available in your country. You have WAF rules, which are more dynamic and smarter. Then you have your signed URLs, which allows for access and authentication from signed URLs and cookies, so they know that you're an authenticated user. You have origin access control and custom headers. That's metadata and letting people know where you are from. Okay, so there's some integration endpoints. With VPCs, security groups can control access to origin servers. NACLs provide subnet level filtering. CloudFront will use specific IP ranges, usually a managed prefix list, and then custom headers for additional origin protection. So some key benefits include DDoS protection, right? So AWS Shield is a standard. So AWS Standard Shield comes in, and then there's Shield Advanced, which has a lot more. Then there's WAF, your AWS Web Application Firewall, which is integrated with this. And you have SSL TLS termination. So this is certificate management at the edge. And then you have access control. So you have more fine-grained access control, which allows for authentication and better usership. So how do you go for creating an S3 origin with OAC? Okay, so you're on the CloudFront console, create a distribution. So origin domain, we select from our S3 bucket, the path. If we had a specific subdirectory, so let's say media slash movies slash US, let's say US Westerns, right? This is just a made up, just to give you a visualization, okay? And then the name will just auto-populates for the origin, and then you can set this up. How's the access? Is it going to be public? Are you going to have control? I would go for the settings just to have a little bit of control over here, and then you select the OAC. You can create one, or well, your best one. Let's go create. This would be the AOC. Do not sign request. No sign request. Did not authorize? No, we'd be okay with this. Let's create this. Yeah, that's fine. And you can add a header if you like, but that's not absolutely necessary. You can enable Origin Shield. It's an additional caching layer, but it'll help to basically speed up how this is transferred. And then you go into your caching behavior and show what's the protocol, what's the compression, what's the HTTP methods. This is a lot more of the detailed stuff that goes into delivering this. Okay, so caching optimization. Yeah, how do you speed this up? This is media. There's a lot of information here to let you organize and better prioritize this. Okay, then you go into function types here. For what is it? CloudFront, Lambda at Edge, which would be event-driven versus the managed. Then you have the web. Okay, WAF, right? Do you not? I think I'd want to enable this. Have the monitor mode. So this counts requests, and this is more active monitoring and incident detection. Okay, so this is $14 for 10 million requests per month. That's a lot. It'll add up. And then you go into your settings. Do you have any anycast lists? Do you want to use all edge locations? Do you want to specify North America and Europe? North America, Europe, Australia. I don't know why. Would it exclude? And you could have an alternate domain for this. Your certificates, your routes, some descriptions, and then your logging, cookie logging, and then you'd go through this, okay? And then at that point, you could add into, let's go through S3, and apply a relevant bucket policy to make sure that this would work from CloudFront. So let's click on this. I'll give you an example of what that bucket policy would look like. Properties, I believe it's properties. These permissions. Yeah, permissions. Okay, permissions, edit. So this bucket policy has nothing, right? So this, that. All right, so this would be an example of a bucket policy, right? Allow AWS CloudFront, or AWS CloudFront, allow the service, get object from this bucket. And we change it to this bucket name. JW, and then we'd have the ID. We change that to whatever, 123, whatever that is, right? And then save changes, and we'd be good to go. Okay. And then for buckets with a KMS, you could change this around. Okay. So I'll show you. Okay. Okay. So this is going to be, this is having a little bit of an issue, but that's okay. That's okay. That's okay. Oh, darn. Okay. Well, this is basically adding this, but for the KMS right here. And it still does the same thing with the ID, CloudFront, as you can see, and then the service IP. Okay. All right. So we'll close that out. All right. And then let's see. So then you could secure the custom origins. Okay. So how do you do that? So we go over here to CloudFront, distributions, CloudFront, distributions. Oh, oh, oh. Well, you basically update the distribution for and edit the behaviors, right? There's literally a tab called behaviors. And you have an origin request policy and create a new origin request policy. So look for a custom secret header and then a forward rule and an authorization, right? And then your application would then only accept requests with that custom header and then drop requests missing that secret header. So that gives you a little bit of way of how this can work to route a lot faster and move a lot better. So we're going to go into, I think, trying to think what else can we do here. Okay, we'll do a little bit about WAF. How about that? Let's do a little more about WAF. So we'll do about WAF, Shield, and Firewall Manager. How about that? Okay. Okay. So there's a deep defense in depth security model, right? Let me show you the way I would map this out. Insert table. Okay. So we're going to go layer, service, section type. Okay. So we're going to go edge, global. This will be CloudFront and WAF. All right, so this is layer 7, attacks, and geo-blocking. All right, and then you have DDoS. DDoS protection. So that would be Shield Advanced. All right, so this would be layer 3, layer 4, and probably layer 7. Yeah, for DDoS mitigation. And then you'd have the load balancer. All right, so that would be application load balancer, ALB, and then WAF. All right, and then this would be application layer filtering. All right, and then, oops. And then you have your network. Oof. Did it be done with security groups? And then this would be instance level. Access control. And then you'd have subnet. That would be the NACL. And that would be stateless network filtering. And then you have your instance. That would be the host firewall. And this would be operating system level protection. Okay, so this would be the security layer responsibilities per service, right? So how do you configure the WAF? Okay, so you go to the console, let's say the services, let's see, what is it, security, WAF and Shield, all right? And then getting started. So you select a region for the regional resources. Let's shield, this firewall manager. Let's go here. Okay. So you create for the name, the region, practice, WAF, CloudWatch metrics name. Yeah, that's good. Got the appropriate region, and then associated resources. We don't have any. Let's try IP sets. We create the IP sets first. That one might be it. Okay. So let's say allowed IP practice IP. Let's just call it practice IP. Track this. Yeah, that's good. And then 10 0 0 0 dash 20. And then we do that. So we could do, how about this? Sorry. So those would be the IP addresses you'd have. IPv4, you create this. You can have this and then create this. You have a block set. It would be here, right? And then for the web ACL, let me see. Yeah, this would be the IPs. Yes. Okay, so then the web ACL, so this would be, we could have the resource like a load balancer, API gateway, AppSync, Cognito, something like that. Maybe CloudFront distribution, and you select the region, and then you could apply all of this and configure this to block IPs. Where? From the IP set, right? And then you could set up an action to block them. And then you could have a whole IP range if you wanted to do that as well. Okay, and you could do rate limiting. You could do SQL injection protection. You could do cross-site scripting protection, and it would be a-okay. Okay, and then let's see. So then let's see what else we can do here. What else can we do here? So where am I looking for this? IP sets, rule groups. Let's see what the rule groups, that would also be useful. So you could have rule groups. So you could create a rule. All right, so you could have the name with the rule, have the metric name, and have the location. Damn. Rule 1. Okay, let's go here. And you could add a rule. Here, have this called IP reputations. Have it a regular rule or rate-based. We'll do regular. If it matches the statement, matches the statement. So let's say it's in the country from, that's fine. Where's the country code? So let's block everything from British India. Oh, what is that? Like the Seychelles? Source IP or the IP and address. So this is how you determine this. And then what is the action? Allow, block, count, have a CAPTCHA, right? And then you could add that rule. And there's all sorts of rules you can keep going from, which we showed you here. Matches there, matches here, right? And you can set this and you can set this and keep setting it and keep setting it and keep setting it. Okay, and then we can show you, looking for logging, web ACLs. So if you have this here, you should be able to monitor. So if you have this set up with this rule that we created over here, or would create, then you can enable logging here and then be able to set this to a log group in CloudWatch and to an S3 bucket. Or in another case, you could use Kinesis Data Firehose, but that's for like near real time. But we don't typically need that. Okay. And you could set different filtering on this. so that you could do via the header or cookies. You could log only blocked requests or requests matching specific rules, and then have those filtered correctly. And so let's go to Shield. Okay. So Shield is a service you have to enable, right? So there's a pricing for it. See, monthly. That's why $3,000 a month. So customers receive a Shield Standard, which Shield Advanced costs a lot, and this protects against Layer 3 and Layer 4 DDoS attacks. It's available on CloudFront, 53, Elastic Load Balancer, and Global Accelerator. And so this will hit your SYN and UDP floods. It'll get your reflection attacks, Layer 4 and Layer 3 attacks, like the volumetric ones. And it has like different mitigations at the network level filtering, traffic shaping, and some intelligent routing. And there's monitoring available via CloudWatch metrics and basic attack notifications. So be careful when you click this button because you're in. All right. But with this, data transfer protection is included. 24/7 DDoS response team is included. Advanced attack diagnostics is included, and cost protection. So DDoS related scaling costs are covered. So I should probably enable this if I'm having this on the public internet. And I'm going to delete. Don't worry, I'm going to delete this profile or this whole account. And so this protects resources configuration. So this will go for CloudFront distribution zones, Route 53, global accelerators, ELB load balancers, elastic load balancers. So that's your application, your network, then the elastic IP addresses, your EC2s with elastic IPs. I mean, this is fantastic when you get into it. And here's an overview page that'll go into. So I'm not subscribed, right? Because once you click this, you're in. But it gives you a lot of real-time attack analytics, a lot of metrics about DDoS, about a lot of information about your layer 7 protection, which I talked about with the WAF rules, automatic WAF rules, and then rules that adapt to attack patterns, and then layer 7 attack mitigation. Right? And so this has a DDoS response team that can do emergency contact during attacks, attack analysis and mitigation, offering you advice on that, and some proactive monitoring setups. So this is more of an upsell. I'm sure it's worth it for an enterprise that has a lot to scale. So just be careful to click that button. But if you're ready to click it, you'll probably get some really good support. Let's go to Firewall Manager. Okay. So Firewall Manager, organizations must be enabled, just to let you know. So we probably won't get this. Okay, so price is $100 per month. Okay, so Firewall Manager must be enabled in the organization master account. And then service config must be enabled in all accounts. And it'll have appropriate IAM permissions for this to be able to be used. Okay, so for this, your goal is to go here, click Get Started. We can't enter our ID number. And then you'll be able to do what you need to as far as security policies. All right, you'll be able to click policies, create policies for standard WAF rules for your load balancers. You'll be able to select the regions to apply it to, and then resources like your application load balancer, and then you have your regular tags. Once you realize how a lot of these services work, you have to figure out what they work best for, and then how to apply that to make your environment more secure, more optimized, more reliable, and more recoverable in case something happens. And then you have, let's see, resource sets. No, they won't let you see anything. You're only getting a snippet of what they have. But yeah, there's a lot of stuff here. But that's okay. That's okay. I'd have to enable all of this stuff. And then you could set security group policies, basically for the policy scope, for what the different resources types. And this is basically having a smarter system than just your standard security groups. So if you wanted to have something more managed by AWS, this is where you would go. And how would this integrate, right? Integrate. This would integrate with what you already have with like security groups and NACLs. So you'd be able to have multi-layer security architecture. So that would mean CloudFront and WAF, right? So it'd be global. And then you'd have you could have like geographic restrictions enabled. You could have your security group set up. You'd have your already dynamic security group set up by security groups and not by IP range. And you could have strict configurations so that with every behavior there would be a response policy, right? So you could have you could set it for age, for content type, what level of protection do you want, and then different policies, right? And you could have layer 2 security for the application for like load balancing within there, around what type of inbound rules, outbound rules you want to have configured. And then for layer 3, for VPCs, you'd want to have this working with the VPC security with the NACLs. So you'd have all, let's say, CloudFront set up for some of the sources, and then you'd have your CIDRs for some sources, and then some security groups. No, then you'd have different NACLs, right? So you'd have like, set this up for what type of protocols and ports would you want, right? So TCP 80, TCP 443, SSH for 2022, for 22, excuse me. And then you'd have that differently for private versus public subnet, or no, it'd be the same. But you would want to make sure that there was, what did you have set up for the public subnet would probably be under CloudFront. For the private subnet, that would be set up for your destination within probably your database layer. Okay. And yeah, I think that covers most of what we wanted to for this, because that gives you a good overview of the topics and shows that there's a lot of managed resources that the AWS has for security. But let's go for API gateway. Okay, so API gateway. Oh, wow. All right, so now we got API gateway. So you see this, okay, you click it here, or go to services tab, and then application integration. Where is it? I thought it would have been there. Business? No. Compute. That's surprising. No, not containers. Developer tools, maybe? No. No. All right, now I gotta go through each one. Hmm. Ah, there we go. Networking and content delivery. That makes sense. All right, sorry this is running longer than I had to. Okay, but so API gateway is a serverless security. It's a serverless way to manage APIs at scale, right? So you pay when your APIs are used, but we want to talk more about the security itself, right? So basically, let's go back here. Nope. So this would be the way that you could show the client flow for the serverless security model, right? So you would have your WAF protection, right? And then API gateway. All right. Okay. And then there we go. Here we go. So this is the client request flow. So you have the internet to the CloudFront, to the API gateway, to the Lambda backend. Okay. So within all of this, you have the WAF protection, geographic restrictions, and DDoS protections. At the API gateway, you have the authentication, authorization, resource policies, and then the Lambda, you have the VPC integration, the security groups, and the NACLs. Okay, and so you're talking about different layers at different levels to protect for edge protection, for API level security, authentication, authorization, network security, backend protection, and rate limiting. Right, so this does a lot of different things for DDoS attacks, cross-site scripting, SQL injections, IP restrictions, VPC access, identity verification. But the built-in features would be a bunch of different things. Okay, so you basically with authentication, you have IAM, identity access management. You have Cognito with the user pools. You have custom authorizers. Then for authorization, you have resource-based policies and IAM policies. For network security, you would have the VPC endpoints and private APIs. For traffic management, you'd have some throttling and then API keys. And then for monitoring, you'd have CloudTrail, CloudWatch, and X-Ray. And for data protection, you'd have SSL, TLS termination at the end or at the edge, and then request response validation. Okay, so let's go into the API gateway. So we can create an API. What type of we want to create? Let's say a REST. We'll build it. All right, so we'll say, what is it going to call? My practice API. Okay, so you can have a description. Um, the endpoint, edge, optimize. Okay, and then some characteristics of this. Okay, let's create this. Okay, and API actions. So you could, you need to update a lot of this, right? So you start adding more to this and then being able to update your documentation with this. And then you start putting in certain characteristics for your security, like global distribution, DDoS protection, WAF integration, SSL, and custom domains. When you start thinking about how all of these are going to be coming in to work with your REST API, how is this going to work? Okay, so you'd have to have something like CloudFront integration. Okay, something like WAF integration. But then where are you going to do this? How are you going to do this? Okay, so let's see. Integrate with an endpoint. Well, I don't have any of this. Okay, let's say I don't actually want to create an API. Um, okay, let's see. Well, I got this API created. What I want to do would be, so I created an API. Let's say, I mean, you'd have to have. Oh man, there's so much stuff we'd have to add in here. I'm gonna exit this out just because I know once this is started, this could be a whole other piece. So I'm gonna exit this out. But at this point, confirm. Yeah. With this point, what you're talking about when you create an API, then you have to create an endpoint for it. And then that endpoint will have to be able to connect it. And then you'd have to create an IAM authorization. And so that IAM authorization, you'd set a policy to work with that API, with the specific ARN that of the API we just destroyed. And then you'd have to create security groups to work with that API, right? And then EC2s to work with those security groups. And then a cognito pool, which is basically if you ever signed into a federated resource like single sign-on, like if you signed in some random site that has, you can log in with Google, Facebook, or Twitter, maybe not Twitter, but definitely Google or Facebook, you create this to have single sign-on authorization, right? So people who have this type of access can be able to access the API that would do programmatic interfaces for your application for you. Okay, and then on the internal side, there's a Lambda function that we will be able to authorize this and then give you what you need for your application. There's a lot of material that goes into this, but what I want you to understand is that there's different layers within the OSI model where you have to have protection enabled. So yeah, let's go. All right, this is what I was talking about. Oops. There you go. This is where you would have to be worried about, okay? Because some of this at the application, this is the human level. Transport and network, this is typically where I work within the cloud environment. And then sometimes the layer 2. Well, really, my work would be between layers 2-ish, definitely 3, 4, yes, 5, some of 6, yeah, encryption, and then some of 7. But that's mostly where the application developers live. So yeah, really 2 through 6 is where I would live. Mostly 3 through 6, but definitely 2. 3 through 5, definitely 2 and 6 as well. That makes more sense. Okay. And from there, you would create resource policies to make sure that everything is working, and then endpoint access so that those endpoints that were able to communicate within the private environment of AWS and not on the public internet would be able to control what they need, access what they need, and be able to deliver what's needed. Okay. And then this could also be configured for stuff on the backend layers like your database. So we showed you your cognito pool, we showed you your API. That gateway can be working with this. But remember, there's a lot that goes into it. Just trying to think, what else can we do? I think we might have most of everything. Oh, okay. One thing. Let me see. Artifact. Let's see. Do they still have this? Okay, so this is something unique. Okay, so this is a self-service portal. This is not really an application or really network, right? So this is where you can download compliance reports. So this would be SOC 123, ISO 27001, anything PCI DSS, and you could find your legal agreements like your BAA, business addendum, business associate addendum. right? For HIPAA compliance, your management agreements across AWS, your security attestation artifacts for audits, and then you'd have your key AWS security, basically the foundations for what you learn, what you apply. You have to understand that this has a lot of the documentation you should have read. If you don't read this, you're kind of cooked. Okay, so here, this is a global service, but it's not really like a service. It basically is, it's your library. So you can go to see view reports. Okay, so look at these reports that you have here. Okay, so accessibility reports. So this would be about people with disabilities. Um, Gosh, this is so these are, oh man. Okay, so this is one thing you're gonna realize out of these 300 reports, only some of them are revolved around America, right? A lot of them are international. See that? So a lot of the benefit of AWS is that a lot of this, because it's spread out, US, Asia Pacific, etc. And there's some I don't even have access to, right? Because of all this, you have different compliance that you have to meet for different environments. And you can get the primary AWS reports that we're talking about, like SOC, ISO, PCI, and then you can get third-party reports as well. Um, and you can do, let's see, let's find SOC. All right, so system organization control, boom. This is all the SOCs. Let's see if they have this. Yep, you got some this. All right, man, this is so much stuff. So basically, you go here, click this, download this. All right, you accept the terms and conditions, and then every report is watermarked though, so you can't publicly share this. So this is for you for internal agreements, right? And so then there's agreements that you work with, right? So this is for BA for different things, like HIPAA would be a good example in the US. Okay, so you'll see your account agreements, your organization agreements, your business associate addendums, and then you have to, you can go through here, you can accept it, download it, and be able to use this. Okay, so this is required to process stuff like private health information in AWS under HIPAA. So this is a must-know for being practical in your job and for the exam itself. And then you can integrate this with your organizations, um, and then enable this so that when you confirm this, this allows your management account to accept all the terms on behalf of all your sub accounts. Okay, so as of right here, this is only read-only download. You accept the agreements, and then if you need to make a custom policy, you can do that for your own account. But basically, it shows like the shared responsibility model that AWS has, where AWS provides their side of compliance, but you're still responsible for how you do this at the application level with all the API gateways and bastion hosts and security groups and NACLs, right? They show what they have documented as far as what they've done for the physical security and development of the cloud environment and what they've done programmatically, okay? But it's your job to be tip-top tight at it. All right, and then let's see. Okay, so let's go for one or two more things. So let's go Route 53. Okay, so we're gonna go for huh. So let's see. All right, so you can do DNS sec implementation. So this is like a hosted zone preparation, which we kind of covered a little bit earlier. But basically, you can go to your hosted zone. Let's go here, select your domain, and then let's see, configure query logging, and then from here, let's see permissions, and then from here you'd have to grant permissions to be able to enable this, and then be able to do different query logs so you can monitor like your DNS query patterns, establishing baseline availability metrics, and you can set up CloudWatch for it as well. And then from there, you could have time to live values for your hosted zones, and then you could edit your records as well. Yeah, I'll probably have to get rid of those. Then what else? And then you can also enable a KMS key for that. So yeah. So you could do a KMS key and encrypt it for Route 53. to be able to encrypt everything here and enable permissions. All right. From there, I think you should be okay. And then you could enable, so you could create chain of trust situations so that your records could actually have your domain and Azure key for this. But this is more complex. So you're talking about how do you have basically super secure records for your DNS, being able to route it, being able to configure it, route it, secure it, and then how do you show monitoring so that you can know what's actually going on. And with CloudWatch, you'd be able to set up monitoring alarms for anything that would go wrong. At that point, I think that covers a good amount of it. Yeah, I think we might have covered enough from Route 53. Oh, you know what? This might be the last one. Let's do one more thing, I think. Okay, how about SES? SES? It's a simple email service. Yeah, let's do that. Let's do that. Okay, so simple email service is like a scalable, cost-effective, and fully managed service for sending outbound emails, receiving inbound emails, so tracking delivery, bounces, complaints, and supporting email authentication, right? But this is a very simple managed process for Amazon. You can use this basically as their mass mailer service, basically. It's good for marketing. From here, you could go to SES, get started. You can either verify an email address or a domain name for like production level mass marketing. From here, you go identities. There we go. And then, yeah, see, I have an email address verified. And then you'd enter the email, create the identity, all right, domain or email address, update that. And then via verification email sent, you click the link to confirm. And you could choose a domain as well. Like if you own a domain, you could add your DNS records to the DNS provider via like Route 53. And then you could request some production level access. So from here, you would, let's see, so it's a sandbox. Yeah, you could set this up here, right? And really set this up so that you fill out a request form. They'd ask you a couple of questions, your use case, and then you'd set up for opt-in lists. And AWS will respond within about 24 hours, right? And you can configure a couple of pieces for authentication purposes, so that you don't get the risk of having email spoofing or phishing, right? So this is good for your organization, so you don't sacrifice your organization's email posture, your email security posture. And then you can also do some login monitoring from here in configuration sets. You create the configuration set here, the name, config set, SES pool, whatever, delivery options, TLS. That would always be nice. Reputation. So this is mounts and complaints, suppression lists. You can do all this. You're archiving, okay? And then you create this set, okay? And then you can send an email. Let me see. I just looked at verified identities. Oh, there it is. Okay, identities. Click. Let's see if we can send a test email. 2 scenarios. Successful delivery. Just checking. Okay, from. First configuration set. It's checking. Who am I sending this to? Secondary. From. Raw. Successful delivery. Okay, we got this. Got this. Got this. Okay. Send the test email. All right, so I'll send it. And we filled out all that information there. And then showed you configuration sets. And we showed you how basically this is very simple. This is a very simple one. So it's like a very simple marketing tool that AWS has. So basically, we covered a lot of material as far as infrastructure security over this lesson. I hope you understand how important this is as far as your organization and the tools that AWS offers that they're managed, and then the ones that you can manage yourself. Okay. The next section we're going to do is identity and access management. That'll be a long one, but hopefully that'll be fun. All right. Thank you very much. Have a good day.